I just want to say thank you, Mrs. Cunningham, for that great introduction. I'm Mrs. Cunningham, and I will be coming to you live, not live, recorded from your computer now for the rest of this lesson. Okay, let's get me off the screen. So here we are in section 1.2. We're looking at ions and isotopes. We're going to start by focusing on the ion. We're working through this first one probably together just to make sure we understand that we can stop and pause and rewind and all the magic that comes with a video version of Mrs. Cunningham. So here we go. First thing first, definition of an ion. An ion is just an atom with a charge. So right there, I probably sped up the video so you didn't have to watch me write slowly, but if you need to, you can definitely pause it. Today we'll do it as a class. Individually, you can pause it as needed. We've talked about atoms and elements. We know that atoms have protons and neutrons and electrons in the middle of them. And we know that some of those things have charges, right? Our protons give us that positive charge. Our electrons give us that negative charge. The neutrons are going to stay out of the conversation for today because they are not impacted by becoming an ion. All right, now, just because we like to make things a little bit trickier, we are going to have crossed out the words. No, you didn't just see me do that because I undid it, but I just crossed out this instead of highlighting anion and cation. These are just two subheadings of ions. They're two types of ions. Okay, so ion, atom with a charge. If that charge happens to be negative, we call that an anion. So this is an atom with a negative charge. Y'all, I got a new pen and it is not my friend. An atom with a negative charge. And see, now I just talked the whole time during this one, so I can't speed it up for you. Sorry, an atom with a negative charge. And then cation, you could probably fill this in without me. This is going to be a positive ion, but in order to stay with the last way that I wrote it, we'll just write it the same way. An atom with a positive charge. Okay, so how do we end up with an anion? Well, if we think again about our protons and our electrons, if we have extra electrons, we'll end up with an extra negative charge. I kind of like to just almost line them up. So here's 3 protons and 3 electrons. We're just keeping tally, right? What element would this be? We got 3 protons, 3 electrons. We got lithium. If we somehow were to add another proton to that, we would not have lithium anymore. Right? It would now be beryllium, element number 4. So that's not an option. When we form ions, we're not changing elements. I just left the page there. And so that's not an option. We're not going to change protons. Instead, we can gain or lose electrons. Okay, so anions are formed when an element or an atom gains electrons. Electrons constantly are shifting around. That is basically the premise of chemical reactions. So this is super common. We are not having a constant shift of protons. That's a nuclear reaction. That's a completely different thing that we'll deal with later. Okay, so cations aren't formed by adding an extra proton. Instead, what happens is we have our 3 protons and our 3 electrons. To form a cation, we would have to lose one of those electrons. Okay, so cations are formed when we lose an electron, and that could be 1, that could be 2, 3, etc. Now, I didn't actually finish showing you up here. If we were going to form an anion, we would have to gain an extra electron. So we would have 1 more electron than protons in whatever element we are dealing with. All right, so both of these would be examples of ions. This one would be a lithium -1 ion. I know that it's lithium because it has 3 protons. And then it's still lithium here because it has 3 protons, but this would be lithium +1. The only difference here is how many electrons they have, right? So it's an atom with a charge, and it really comes from changing our numbers of electrons. Okay, I'm going to let you know lithium -1 would never happen, but it's fine for our sake of conversation. Later, we'll find out why. Okay, and so as we have mentioned now multiple times, we'll just get it in writing. An anion has more electrons than protons. That makes sense to us because it has a negative charge, whereas a cation has more of our positive protons than our negative electrons, which makes sense to us because it has a positive charge. Some ways you can remember this. I have the best ways to remember this. Not really, but it's okay. One way is that some people feel that cats are positive. I'm in that camp. And you know, I'm going to get you in that camp. I'm going to try to drag us. Let's see if I can figure this out here. Woo, look at this. Cat ion. Meow. Cat ion. It's a very positive cat. And if that's not doing it for you, I like to sometimes draw a plus sign with 2 eyes, a little mouth, and you just wait for it. What? Check that out. Cat. That's cat ion. It's a happy cat. No? Okay. Well, my anion ones are better. Okay? Because anion looks a lot like the word onion. And onions, I think most people agree that onions are kind of gross, and so that's a negative onion anions. No? Okay, I got one more for you. Last chance to remember this is that anion, the first 2 words of anion, look a lot like our first 2 letters in ant. And so here's my drawing of an ant. And guys, if we fill this in and you really squint, or if we really zoom out right there, do you see how that kind of looks like a negative sign? Right? It's an ant and a negative sign? No? That doesn't help either? All right, well, fine. If none of those work for you, you can just remember that cat ions are positive ions, anions are negative ions, and ions are an atom with a charge. This video goes over my 6-minute limit, so I'm sorry. I do apologize. So, oopsies.